Well, again, our discussion is from kinematics, that is motion in a plane, and we are continuing with the projectile motion. However, earlier we have discussed about the projectile and the path of the projectile, that is trajectory, and now we are again starting with the projectile motion. This is in continuation to part 1 of the projectile motion. So now our discussion is mainly from the horizontal projectile motion top to the ground projection. For example, like there is some body at a certain height, and from that height we are uh, firing an object, or we are throwing an object parallel to the horizontal. Then the moment we will just project that body, immediately it will start bending towards the earth with a zero acceleration. So horizontal projectile motion top to the ground means from the top we will horizontally project the body, and the moment it will be projected, it will start coming down by making parabolic path towards the ground. Suppose a body is thrown horizontally from point O. Check up the figure. So O is a point from where the projectile is thrown, and its initial velocity is u. Height of O from the ground is h. That is, the projectile is fired from height h, that is at O from the ground. So body is thrown horizontally from point O with velocity u. Height of O from ground is h. Suppose x-axis be along horizontal, y-axis be vertically downward. Origin is O at a point of projection as shown in the figure. Suppose the particle be at P at time t. The coordinates of P are x and y. So in the figure, point P is indicated, its coordinates are x and y. That is, x is the horizontal length and y is the vertical length. According to the figure, O is the origin, h is the height, u is the velocity of projection along x-axis, that is horizontal to the plane. The moment body is just released from O, moving horizontally, it will start bending towards the ground. So at point P, we have taken two components, Vx, vertical, that is horizontal component along x-axis, that is u. Other component is Vy, and that is equal to gt. We know that velocity vertically is v is equal to u plus gt, but u is 0 initially along y-axis, therefore Vy is taken as gt, and the angle of projection is taken as beta. So we are finding that horizontal is making angle beta with the trajectory. So the path of the projectile is parabolic. That is, when the projectile will be fired from O, it will make a parabola and will come to the ground. R is representing the horizontal range. So R is the range of the projectile, and that is called horizontal range. H is the height from where the projectile is fired. Now, the coordinates of P are xy. Distance traveled along x-axis at time t with uniform velocity, that is velocity of projection, and without acceleration. So, in the figure, it is mentioned Vx is equal to u and Vy is equal to gt. So, the horizontal component of velocity is Vx, and that is equal to u, and the horizontal displacement is taken as x, and displacement is given by formula velocity into time. So x is taken as u into t, and this is marked as equation number 1. Displacement along vertical direction is y. To calculate y, we have to consider vertical motion of the projectile, initial velocity in the vertical direction, and the initial velocity in the vertical direction is uy, and that will be taken as 0 because the projectile is projected horizontal to the plane. Now, acceleration along y-axis or y direction is represented as ay, and that is taken as g. That is acceleration due to gravity. So, y component or velocity along y-axis is ay into t. That is the y component of velocity at time t, and vy, that is velocity along y-axis or y velocity component along y-axis, that is gt. This is equation number 2. As body were dropped from height, resultant velocity at time t is given in the vector form, that is v is equal to vi cap plus gt into j cap. Now we wanted to find the resultant velocity. We will take the coefficient of I and the coefficient of j, then we will square them and add them, and then we have to take the square root of the addition. So v is equal to under root u square plus gt square. If beta is the angle, like in the figure is shown, if beta is the angle of the velocity with x-axis, that is horizontal, then tangent beta, tangent means taking perpendicular over base. So it will be taken as gt over u. Now y is taken as half gt square. Normally the equation is s is equal to ut plus half gt square, but because u is 0, so y is taken as half gt square. This is marked as equation number 3. Now, in the next step, we have taken y is equal to half g, and for t we have computed the value, that is x over u, and we have taken the square. This is from equation number 1. We have calculated t is equal to x over u. Therefore, this formula will become y is equal to half g into x over u whole square, or y is equal to, now we will take g over 2u square. We will open up the brackets. So g over 2u square into x square, or y is equal to kx square. X square is as it is, but g over 2u square is taken as equal to k. So k is equal to g over 2u square. K is constant, and this is the equation of parabola. A body thrown horizontally from a certain height above the ground follows a parabolic trajectory till it hits the ground. This has been clear in the earlier lecture also. That is, whatever body is thrown horizontally from a certain height, immediately it will start bending, and the path traced by that body is called trajectory, and the shape of the trajectory is parabolic. Therefore, a body thrown horizontally from certain height above the ground follows a parabolic trajectory till it hits the ground. And the range is always represented by r, that is the horizontal distance traveled by projectile. Now, time of flight can be calculated by function 2h by g square root. The range, that is horizontal distance, that is calculated by velocity multiplied by time of flight, that is r. R is equal to u multiplied time of flight. Then we will take u into, and for time of flight we have computed the value 2h over g. The third thing is velocity when it hits the ground, that is vg, and that will be u square plus 2gh. This we have worked out from an equation, v square minus u square is equal to 2gh. So velocity will be taken as the square root of u square plus 2gh. Now, there are certain examples we have to discuss, like for example, when the angle of elevation of gun are 60 degrees and 30 degrees respectively, the height it shoots are h1 and h2. Then we have to find the ratio h1 over h2. We have basically to use the formula for a projectile for a particular elevation. The height is given by function u square sine square theta divided by 2g. But according to our question, theta is 60 degrees. Therefore, height h1 for the elevation 60 degrees is taken as u square sine square 60 over 2g. If we calculate it, sine 60 is taken as root 3 over 2. Then we take the square of it, and the net result will become 3u square over 8g. Now, for the projection of 30 degrees, again we have to use the formula, that is h2 is equal to u square sine square theta, but for theta we will put 30 degrees. So h2 is u square sine square 30 over 2g. Now, sine 30 will be 1 over 2. So, if we square the number, it will become 1 over 4. And after net calculation, it will become u square over 8g. So, h1 over ht means that 3u square over 8g is divided by u square over 8g, and the ratio will become 3:1. So, h1 over h2 is 3:1.